So welcome to creating an out parameter method. In this video, you're actually going to create a method that uses out parameters yourself. It's going to return a Boolean, but actually it's going to mutate the state of something called hit location. So it's going to use out parameters, and that will give you a much deeper understanding. So please take the time to do the challenge in this one and spend a good hour on it if you're a beginner. But if you get stuck after that, then do just keep watching. Okay, let's take a look at this aim towards crosshair a little bit more closely. I don't think I explained in the last video that the reason we are checking that we have a controlled tank is it doesn't make any sense to start aiming towards the crosshair on the screen unless we're controlling a tank. So what we need to do now is what it says in the pseudocode, and I want to use an out parameter for this because the engine uses out parameters a lot, and I want you to get used to not only using them but actually creating methods with out parameters yourself. And that's going to be your challenge for this video. But for now, let me explain how I plan on building it up. So we're going to make ourselves an F vector, and you may as well follow me along with this for the moment, and it's called hit location, and it's going to be an out parameter. Now I'm going to stop doing the whole hash define out at the top because that's not common in the engine code, and you need to start getting your eye in, as it were, start getting used to seeing out parameters when they exist. So we're going to have this F vector look location. All right, hit location rather. Now what I want to do is I want to print this out to start with. So let's just go ahead and UE log this, and it should just be a 0 vector to the log temp with warning verbosity using the text sub macro inside a macro. And we're going to say, now I'm just going to say the following. I'm going to say hit location dot. Now you'll see there's a toString. Why is it a dot rather than an arrow? Because it's it is an actual variable here. It's an actual member. It's not a pointer. Dot toString, and that's a method. So check your brackets are matched. So that bracket there, if you select it, is matched with this one, which is good. And let's go ahead and see if we, at least on every tick, because aim towards crosshair is called, remember, from tick, we should be getting a 0 vector logged out. Now there is a deliberate mistake here, by the way. This will not compile, but it would be a very easy and innocent thing for you to do here, right? And you might think that it's because we're missing a star, but let's just see what the error messages are for the learning. Hit location undeclared identifier, toString must have a something or other unknown type, and function doesn't take 4 arguments. So the first thing you may try is putting a star, going, oh yeah, that old chestnut. This thing needs to be converted to a tchar star. So I'm going to put a star in front of it. So yeah, you can try that. Let's see what we get now. It'll get rid of some of the errors, I think, but I don't think it'll get rid of all of them. And then we'll look a bit more closely because this is something you may well come up against and it would frustrate you, and I want to help you. So we have here the log function does not take 4 arguments, okay? And the reason for that is it's interpreting whatever this text macro is doing, it's interpreting the result as 2 separate arguments. So the solution to this type of thing is actually to use the format operator. It's to do something useful. Say text and then say hit location, colon, and then your %s or whatever. Well, it needs to be %s for string. Close your braces and then the comma for the hit location. Now check your bracket matching. And now I think that this will work because actually this whole thing will be considered just that third parameter. I know that's really strange with where all the commas are. You pretty much just have to remember this because we don't want to go and dissect exactly how all these macros work. But the UE log macro expects 3 parameters, 1, 2, 3. And this third thing I have highlighted on the screen is itself just a parameter in aggregate. And let's try that. I think that'll work. And it'll also be more useful because it'll log hit location rather than just logging some random thing to the console. It's always worth labeling what you're logging so you know what you're looking at. So that did work. And if we play now, we get hit location, some massive number because it was never initialized, and then 0, 0. So normally you would initialize your variables, but as we're going to use this as an out parameter, I'm actually not going to bother. Okay, so far we've done pretty much nothing apart from learn a little bit more about the necessity of using these format operators or the trick here. So what we want to do is we want to get the world location of, or not if, but of the line trace through the crosshair. What that means is when you're playing the game and the crosshair's up in the sky, it's probably going to hit nothing. But if it hits the terrain, we want to know it's hitting the terrain, and then we want to return the world space location of where it's hit so that the aiming system can now aim at that mountainside. That's what we're aiming to do. Excuse the pun there. Now what I want to do is I want to make a method that does all this in one go. And that method's going to be called getSiteRayHitLocation. And I actually want you to write the outline of that method to take in an out parameter, and the out parameter is this hit location. So you may have to stop and think about this or revisit a previous section depending on how advanced you are. So I want you to write get site ray hit location. It's going to return a bool, and that's going to be true if it hits anything and false if it doesn't. Now listen, I don't want you to fully implement necessarily this method. I just want you to write the signature of it and get it laid out. So it's going to return a bool, and it's going to be a constant method because it's just going to return an out parameter. It's not going to mutate any of the member functions of this tank player controller. We want to return an F vector called hit location as an out parameter, but remember you need to use an ampersand somewhere. The reference, or is it address of, operator, depending on whether it's a prefix or postfix. Remember, towards about 2/3 of the way through, I think, Building Escape, we talk about this in references and pointers, the lecture. As a bonus, you could pseudocode the actual functionality of this get site ray hit location method. Its purpose is to raycast through the dot, as far as we're concerned, into the landscape and determine whether we hit anything. If we do, we return true, and as an out parameter, we return where in the world we've hit, and if we don't hit anything, we return false. All right, and as a super bonus, you get it working, but that's a bit much. And if it works, then your log will actually continuously update with the location of where that crosshair is aiming at. But as I say, that's super advanced and really only tried if you want an extra challenge. It's just for the more advanced people. So go ahead, pause the video and have a go at all that now. Do have a go at this one. It's going to take just a tiny bit of thinking about, but you've used out parameters before, so go and see where they were used and see if you can remember how to do it. Okay, welcome back. So here in the player controller, we've got to think whether we want public or private for a start. Well, I'm going to suggest it's going to be private because no other method outside of this needs it. It's a helper method. So we're going to return an out parameter, and it's going to be called true if hit landscape. All right, now it's bool. I said I wanted to return bool. We said it was going to be called get site ray hit location, and we said that it was going to take in and, well, not take in, but mutate or change an F vector, and that F vector was going to be called hit location, and that the method was going to be const. But there's one more thing. Out parameters work by passing references to, and in this case it's going to be passing a reference to an F vector. This will make a little bit more sense in a minute when we see it in context in the implementation. So I'm going to copy that signature, put it straight in here. Of course, I need the class name, like so. Okay, long old method definition, right? So, or signature, as you call it. This thing here is the signature. So what's actually happening when I pass this in? Well, let's make the call. We're going to go if get site ray hit location. Passing in hit location as the thing that's going to be used as the out parameter, then all of this lot, like so. Okay, so the thing about this if get site ray hit location is it actually does anything. It has a side effect. It doesn't change anything, but it has a sort of side effect, which is that it's actually going to ray trace later on when we implement that, okay? And if that's true, then we're going to log it out. So this get world location of line trace, that's going to be implemented in here. If it hits the landscape, return true. Well, we know that. I'd actually better put that in as a comment, I think. The F vector ampersand reference is saying that we're going to create a variable here called hit location. We're going to pass what looks like hit location itself into get site ray hit location, but it's actually a reference to that. And then somewhere later in our code, we're going to change the value of hit location. So I don't like this architecture, but you'll see it all over the engine, and you do need to make sure you know how that works. We'll leave this as a to-do, because later we're going to tell the control tank to aim at the point. All at the moment we wanted to do is get you this far, that we actually set up an out parameter. So in the next video, we're going to look and see what actual values we're going to put into this thing. But for now, I'm going to return false to say, i.e. we haven't hit anything. And I'm just going to return I'm going to just set hit location to something recognizable. F vector 1.0, let's say. And what that's going to do is it's going to return an F vector that's 1, 1, 1. and then we'll be able to recognize that. So we should go through here, this should go to true, and then we should log the hit location, and it should be 1. And that proves that all our code is executing properly. And then in the next video, we'll talk about how get site array hit locations actually going to work in practice. And it'll be a good further exercise. So I hope you got on well with that reference challenge and you were able to make this out parameter based method. If this is all sounding gobbledygook to you, then just stick with it. You'll get used to it. You'll get used to the idea here. I really want you to be able to read engine code and read code written by other people. So I'm kind of dragging you through the mud a little bit. So let's have a look. That all looks okay, apart from we're not getting anything come out every hit. So it's obviously hit location. I returned false. I need to return true. So what happened there is I was returning false. So this wasn't evaluating, so it was just jumping straight out. So we need to return true. We're pretending we've hit something, and we're pretending that we've hit something at a location of 111. So I'm playing the game now. It's compiling in the background. When the hot reload completes, I expect the log to fill up with exactly that. Hit location 111. Great. So we are a step further through our process of setting up the whole architecture. Before we go, let's just remind ourselves what that whole aiming architecture was. I'll go through the slides and show you that one. Remember that what we're trying to do here ultimately is we're trying to have a tank. Oops, let me go back. A tank possessed by either an AI or a player. The AI was going to tell it where to aim, or the player is going to tell it where to aim. Actually, it's the same aim at method. And then that tank will delegate out the aiming to an aiming component, which we haven't made yet, which will finally tell the blueprint to do some actual rotations of turret and barrel, respectively. So it's a long old haul getting this working. This is the second most complicated thing we're going to do in this section. The most complicated will be the actual movement of the tank, which of course we'll be gagging to do the moment we can actually aim our tank. So anyway, that's it. I hope that's all made sense to you. I'll leave the code on the screen. I think that might be helpful to you so that you can see what we've actually written here. And that's it. I shall see you in the next video. Remember to commit your work to source control.